So we'll see the problem, one of the problem in the per unit reactance diagram. So per unit reactance diagram, we have to draw, this is a single line diagram given. So for this single line diagram, we need to draw a per unit reactance diagram. Okay. So here it is, one generator is there and two transformers are there, one transmission line and two motors are there, and the specifications are given in the single line diagram. So with the help of this, we want to find out the per unit reactance diagram for the given problem. First, here the base values are given. Base values, the problem is mentioned, you should take the base values from the generator side. Okay, so from the generator values are taken as the base values. Okay, so the base value, base MVA new is 300 MVA and kVB new is 20 kV. And since generator ratings and your base values are both the same, so you will be getting the reactance of the generator XPU new will be the same as your XPU old, so which is 0.2 per unit. And then we will move on to the transformer T1. For transformer, this is the XPU change of base formula. Since for transformer, they have given you XPU old, so with the help of this, you should find out with the help of this change of base formula, you should find out XPU new. So XPU old into kVB old by kVB new and your MVA new by old. The old is nothing but the ratings of the transformer, so which is provided here. 350 MVA, and this side only you know the kVB old. So kVB new you know this side. So kVB old from the transformer it is 20. Okay, and your MVA old is 350 and your 10% is a XPU old. So they have XPU old is 10%, so 10 by 100 is 0.1, and kVB old is 20 and your MVA old is 350 and MVA new is 300 and kV new is 20. Okay, so you can calculate with the help of this formula. If you calculate, it is 0.0857 per unit. And then for transmission line, before going to transmission line, you must know the base kV on the HT side of transformer T1. So with the help of this formula, you will be finding out what is the base kV on HT side of transformer T1, which is LT side base kV and your HT and LT rating of transformer T1. So if you substitute, you will be getting the transformer rating as your base kV, which is 230 kV. Then with the help of this, you find out the base impedance. Since your per unit impedance is actual by base, if you find the base impedance only, you will be able to find out the per unit impedance. So the base impedance kV square by MVA. MVA throughout the system it is 300 MVA and your kV is 230, which we found here. So it is 176, and your actual reactance is nothing but they have provided you 0.5 ohms per kilometer. Per kilometer it is 0.5 ohms. For 64 kilometer you should calculate, which is 0.5 into 64 is 32. So if you substitute actual is 32 and your base is 176, you will be getting 0.1815, that is your per unit reactance. Then for transformer T2, will be able to use that base kV 230 kV on the HT side itself. Otherwise, you can also find out from the LT side also. Both we can do. Before that, this is a 3 single phase units transformer. Okay, so we need to first we should find out the voltage ratio. Since if for 3 single phase units, the voltage given for star side is 127. Star side always VL will be V phase. VL equal to root 3 V phase, and for delta it is VL equal to V phase. So you should multiply into root 3 to convert it to your VL, that is a line voltage. So you are multiplying into root 3, so to convert it to phase voltage to line voltage is 220, and your delta side VL equal to V phase, so 13.2 is just like that we have to take it. So this is your voltage ratio for T2, and your same with the MVA also. It is given for each unit it is 100 MVA. You can see in the problem it is provided for each unit it is 100. So for 3 single phase units, 3 into 100 will be the power will be 300 MVA. That is your power. Same way here you can see it's star side 127 and delta side 13.2. This should be multiplied into root 3. Okay. So now you can find out the per unit reactance. Same formula we are going to use it. Okay. So the old XP old is 10%, so 0.1, and kVB old when you old is 13.2. I have taken in the LT side 13.2. You can also take in the HT side. HT side you are going to take, both will be your old and new. This will be, we have calculated it is your 220 by 13.2. 220 is your rating, but already we know the kV new on the HT side is 230. Okay, if you are going to substitute here, you should have a kVB old is 220 and kVB new is 230. Okay, this also is possible. Here I have taken LT side rating. So LT side we have calculated, which is going to be with the help of this formula we have calculated. Base kV on LT side of transformer T2 is base kV on HT side into LT by HT rating. This is the formula. So 230 into 13.2 divided by 220, which is you are getting us 13.8. That will be a base kV new on the LT side, and your kVB old on the LT side of the transformer T2 is 13.2. So your XP old is 0.1 and your MVA new is always 300, and MVA old is 3 into 100, that is 300. So this will cancel, so you will be getting 0.0915. This is for transformer T2. And for motor 1 and motor 2, you should find out the XPU new. So with the help of same formula, change of base formula. So old the ratings of the motor, and your new should be already we found in the LT side of transformer T2 is kVB new is 13.8, MVA new is always 300. So substitute here, you will be finding out 0.2745, that is your motor 1 rating. And for motor 2, also the same procedure. If you follow, you will be getting again the kVB new is 13.8, MVA new is 300. Other the old ratings are from the motor. So if you substitute, you will be getting 0.549. This is your motor 2. That's all. We will be able to draw the surface for per unit reactance diagram with the help of all these values. So this is the equivalent circuit for the generator. This is per unit reactance diagram, also it is called as per phase analysis. You are analyzing only one phase. So your equivalent circuit also, single phase equivalent circuit. This is for generator, and this is for transformer T1. This is for transmission line, and again this is transformer T2. This is for motor 1, and this is for motor 2. So this is about per unit reactance diagram. Thank you.